Yeah, thanks for the introduction, Marco, and thanks for all of you to being here. So I'm Rodolfo Cavicchioli with the Luve Group, a multinational company that produces heat exchanger for refrigeration and air conditioning. I guess my presentation is coming. Yeah, so we will see the technical and economical consequences of the use of CO2 gas cooler with less than their declared nominal performances. So this is a very important topic. Of course, we only have 10 minutes today, but we can, if you are interested, I can share you the simulation that we have run that demonstrate how the underperformance gas coolers impact on the overall efficiency of a refrigeration plant and overall cost, running cost of the system. So CO2 is a good refrigerant. It has some very good features. So it's natural. So there is no need to recover, reclaim, or recycle the thing. It's cheap. There is a large availability in nature. It's an environmental friendly refrigerant. So no ODP and a very low GWP. Of course, GWP is one for CO2. Then it's safe. It's a refrigerant that's not flammable. It's not corrosive. It's miscible in standard oil. It has a low compression ratio and it has high refrigeration capacity. So it's a refrigerant that has great characteristic, and thanks to the advance in the evolution in technology, this has become a great refrigerant. So yeah, recently has been introduced the Eurovent certification for the high pressure side of the CO2 transcritical system. So all the Luve heat exchangers, when it comes to CO2, they are Eurovent certified. So both the unit coolers, both in their commercial and industrial denomination, and since last week, our gas coolers, we are the first company to have gas coolers that are Eurovent certified. What does being Eurovent certified means? So with the Eurovent certification program, what you have certified is the standard capacity of the heat exchanger, the fan power input, the energy ratio, energy class, the air volume flow, the refrigerant side, pressure drops, and the noise level. So yeah, all our gas coolers since Thursday last week are Eurovent certified. When it comes to the Eurovent certification for gas coolers, the Eurovent certification basically covers two different working conditions. So we have the so-called standard condition SC20 and the standard condition SC25 that basically cover the operating mode in subcritical and transcritical operation. So a CO2 gas cooler should be tested under the Eurovent standard condition, both in subcritical and transcritical, to get the certification. In addition to that, so the fact that the units must have their performance tested in both the SC20 and the SC25 performance, there are other conditions in which the units are verified. In particular, within the Eurovent certification exists some coefficients that that make a correlation between the standard conditions in transcritical operation to some other conditions that are used to, how can I say, predict the capacity in conditions that have different operating pressures and different ambient conditions. So we have three different stages, basically: low temp, high temp, and medium temp with different working pressure. And a gas cooler that is Eurovent certified must be coherent with the correction factors that Eurovent has identified together with the manufacturers. So, oh yeah, that's important. Eurovent makes sure that the factors are applied accordingly before certifying the gas cooler manufacturer. So that's a very important thing. So what I want to show you is what happens in case you are using a CO2 gas cooler in your refrigeration plant that has a capacity, a real capacity on the field that is different from the declared capacity. So I've run with the support of our R&D department a couple of simulations. So to verify what is the impact on the annual power consumption. So basically the related cost of running a system of a refrigeration plant. The assumption behind the simulations are the following. So we have two different levels, temperature levels. We have the medium temperature with suction and -8 and the capacity required at 250 kilowatts. We have a low temperature with -30 suction and a capacity of 100 kilowatts. We have a design ambient temperature for the high pressure side that is 35 ambient and design maximum operating pressure that is 95 bar. The design gas cooler capacity, so the required capacity is 490 kilowatts, and we have identified when we run the simulation that 0.25 could be a good number when it comes to the cost of energy. Of course, due to the recent situation with the war and everything, the price of energy is much more than that. So what the numbers and the cost of the running cost of the system, of course, will increase due to the fact that the cost of electricity is much higher than that. So the first simulation, we are considering that the design capacity of the gas cooler is in line with the real performance of the gas cooler. So we call it case 1, and we obtain the following results. So in this graph there, we have like the gas cooler thermal power, the evaporator capacity, the working pressure, and the CO2 outlet temperature. So we can see that at 35 ambient, we have maximum operating pressure at 95 bar. That was the design condition. We have the economic simulation that demonstrates that the gas cooler fan electricity cost is the least part in the system. So we have 8,134 euros of operating cost, annual operating cost for the gas cooler itself, but we have 355,000, that's the operating running cost of the compressors. So in this first case, we have this 362,000 of operating cost of the system. And again, this is considering 0.25 euro per kilowatt hour of energy cost. In case, the working pressure is 95 bar in this case. Again, we are using a gas cooler that has the real capacity that has been designed for. In this other simulation, there is we call it case number 2. We are using a gas cooler with a non-certified manufacturer that is applying a 25% of what we call, let's say, oversize coefficient, and we'll see the results with the same working condition that we have seen in the 2 slides before. So in this case, we can see that the cost of the running cost of the compressor are almost 15,000 euros more than the previous case. And that's because we are running our gas coolers at 100 bar to guarantee the heat rejection that we need at the high pressure side. So, of course, the compressor rack has to compensate the lack of capacity of the gas cooler to guarantee effect the evaporator. This means the compressor have to compress gas at 100 bar, so the discharge pressure will be 5 bar higher than in the design condition. So the system maximum pressure is now almost 5 bar higher than in our design condition, and the impact on the annual cost is not negligible. So we have this almost 4.2% in plant electricity consumption. That, of course, when we consider that the compressor consume a lot of energy, it's in this specific case that means 15,000 euro per year. But again, this assumption was based on a cost of energy that is 0.25 euro per kilowatt hour. If we consider 0.4 or 0.6, there is a cost of energy in some countries. This difference will be much higher than that. So, of course, the higher gap between the declared capacity of the gas cooler, the higher is the impact on the plant consumption. So the gas cooler, being such a key component of the system, must be sized, and it's important to have the declared on the field the declared capacity, because otherwise what you will get is a transcritical CO2 system that is not efficient and with let's say 4.2% more power consumption than the expected. So just to sum up, CO2 is a non-toxic, non-flammable natural refrigerant with a low environmental impact, and the use of CO2 as a working fluid in refrigeration is well established and more popular. The European program, the European program for heat exchangers involved the major manufacturers of the market. The program is based on a voluntary approach and certifies the product performance through selection software validation and product testing in a third-party laboratory. So yeah, and a manufacturer to be certified have to have a software that is approved and verified, and their units must be tested in a third-party laboratory. That's very something. CO2 unit coolers and gas coolers are included in the certification, and due to the peculiar properties of CO2, dedicated performance evaluation process was established. So when comparing the certification of a standard condenser, we only have one working condition that the Eurovents committee is verifying. When it comes to gas coolers, we have two different working conditions, a subcritical, so when the heat exchanger operates as a condenser, and in transcritical when it operates as a gas cooler. And to avoid the installation of CO2 system, that the installation is intended only as a greenwashing operation, it's necessary that the components of the plant, including the heat exchangers, are designed and run efficiently. And that's very important because it's not just CO2, it's CO2 that operates properly, and it's CO2 that operates efficiently. That makes a CO2 system a valid alternative and not just a greenwashing process. So Eurovent mark is a warranty in this sense, certifying the reliability of the performance of the CO2 unit coolers and the gas coolers. So yeah, with that I'm done. Thank you.